Welcome to the next video lab discussion in support of the complete PAC Learn series entitled An Introduction to RS5000. The name of this lab, this was part of the conveyor code lab in general. This section, found approximately on pages 106 through 111 of the manual, was on reusing code. So this was a lab project. Once you had completed all of the code for the conveyor, including production code, doing the GSV to get the time and date so you could do your shift information, once all of that was done for one conveyor, then in this lab you basically duplicated it in terms of reusing code, duplicate programs. Welcome back. This video is going to discuss the next section of the lab book, the RS5000 Volume 1 lab book, and the title of this section of the lab was Duplicating Programs, Reusing Programs. Now remember that this is a subset of task, programs, routines, and add-on instructions, which that is the granularity of the code for the Logix Engine. You have task, multiple tasks, and within a task you can have multiple programs. Within a program you can have multiple routines. Within a routine you can have multiple add-on instructions, and within an add-on instructions you can have multiple add-on instructions. So you can nest add-on instructions inside of add-on instructions. You can nest routines inside of routines, but you cannot nest programs inside of programs or task inside of tasks. So task would be the most coarse grain of your code, and inside of a task you would have programs. And each program can have multiple routines, and those routines can be nested typically 6 or 7 levels deep. And add-on instructions as well can be nested a certain number of levels deep. That's covered in the section on add-on instructions. That probably is in volume 2. I don't think we're going to have space for it in this first volume. Anyway, duplicating programs, reusing programs. You knew up front that you had several of these process buffer conveyors installed. Why do more than one and then have to debug more than one? Do one, get it right, and then copy your work. You went out and you commissioned the first conveyor section on the shop floor, the plant floor, and once you had it working perfect, then you came back, sit down at your desk, and now you're going to do the following procedure. So we're going to save our program always. Now, if my graphical user interface is organized a little bit different than yours, because this toolbar for you is probably in between the main toolbar and the online toolbar. I move stuff around to give us a little bit more vertical space. I would get rid of some of it to open this space up, but we need to tap into at least this toolbar, and this one, and for all intents and purposes that eats up the space. So we saved. Let's go offline. These changes could all be made online very carefully. You can do almost anything online that you could do offline, but if you make a mistake you can't correct it online. So once done, you cannot edit it online. Once the Logix Engine places the instance somewhere in memory, it's not allowed for you to go and edit that instance. You can delete the instance and reinstantiate it the way you want it or where you want it, but you can't edit it once it's created online. You have to go offline to edit it, or if you're online you have to delete it and redo it. We're offline. So the first thing we're going to do is we're going to go over here to our program. See, we have a continuous task. You can tell by the little swirly right there, clockwise swirly. We have one program, and inside the program we have main routine, conveyor, and production. And we have these tabs down here: main routine, production, and conveyor. Now those aren't in the same order as they were over here. That's because we opened them in a different order. However, if I wanted to change that, I could just right click on production, close routine. See, now I've only got two tabs. And then go back here and open up production again. Now they're main routine, conveyor, and production. There are times when you want to have these tabs in a specific order for ease and quickness of access. And if that's the case and they're all messed up, you can go up here, hit the X, and they're all gone. And then double click, double click, double click. Open them in the order you want them. Okay, so we're going to go to main program. So we want to duplicate this. But what we want to do is copy it. So we're going to right click on main program, go to copy. Now it's on the clipboard. You know that. Go to main task and paste. And voila, there it is. Now notice that you can't have two programs with the same name, so it added something at the end. If we were to do that again, right click, well, we already had it on the clipboard, we didn't need to copy it again. Paste. Now see, you got main program 2. However, we don't want, this is a good important point here. I did this to show you just keep on duplicating. However, you can't, even though we're offline, you can't delete that because it has things in it. You have to empty out each level and work your way back up and then delete it. So I might as well show you that. We'll go to production and we'll delete all the rungs. Go to conveyor, delete all the rungs. Go to main routine. And go to program tags. Oh, we've got to be in edit tags to delete. Just select them all, delete. Now, nope, see, it still is grayed out, so I still need to do a little bit more. So I'll delete that routine. Delete that routine. Now right click, it's still grayed out. So I think the one thing that I didn't do, even though program tags is empty, is I have to go up to the main task, go to properties, go to the schedule, select that, and remove it out of the program schedule. Now it's unscheduled. Now I can delete it. So I may have had a few extra steps in there that weren't necessary, but you get the point. You see, I created that with the flick of a wrist. In an instant, it was created, but getting rid of it was a different matter. So it's easy, and we're offline. If you were online and made that mistake or wanted to do that procedure, it's much more difficult. Here's our two programs now. And so we're going to change the names now. We're going to select the properties for the main program. And you can't see it. It's all the way at the bottom of the list here. It's off your view, but all the way down at the bottom will be properties. And we're going to call this line 1 conveyor. And we're going to do the same thing for the second one. Properties are all the way down at the bottom where you can't see it out of your view. Line 2 properties. Okay, now we've got two programs, line 1 conveyor, line 2, whoops, Properties. Okay, right click, properties. I was busy thinking properties, not paying attention. One of the challenges of recording this material, because I don't have a script and I don't rehearse it, if you have a script, it's too confining. It just doesn't allow for things that pop into your head that are inspirational. And if you rehearse it, no matter how much you rehearse it, you actually waste some good points of wisdom. You remember them when you rehearsed, and in your mind you think you've said them, but you said them when you rehearsed and not when you were actually recording. So also when you're recording material like this, you're thinking not just about what you're doing, but what's next. And that's a little distracting, and sometimes you blend what you're doing next with what you're currently doing. So I apologize for making you sit through not just the mistakes, but that lengthy explanation you just got. Okay, next step is we're going to alias tags to what we had for IO tags. We'll go to, well, I'll open up the program tags here. So here's the program tags for line 1 conveyor, and I had you compare them. You can't tell the difference because they're actually identical. The two tag databases, program tags, they are 100% identical at this moment. And the tags that you're looking at will remain identical in their text, but we're going to alias some of them to real I/O. So we'll go up to line conveyor 1 first. In the manual, I brought up the controller tags, which would have I/O in them, and I see now that we didn't add the I/O. I mean, I had you add the I/O in the lab, or it was already there when you started the lab. So I'm going to very quickly, I'm going to pause for a minute, add the I/O, and be right back. Okay, now you see that there's two I/O cards down at the bottom of your controller organizer. A 1769 OB16P in slot 1 and a 1769 IQ16F in slot 2. So there's an output card and an input card. Typically I put input cards in the early slots and output cards in the later slots, but this particular piece of hardware was already assembled this way, and rather than change it, I thought, well, I'll just do it different, because it really doesn't matter. There was a time when it mattered in some of the older chassis, and you had some convoluted hardware structures called complementary I/O, in which that is covered, by the way, in one of the lectures series, talking about the original rack of memory back in the PLC 2 and 5 days, 1771 I/O chassis, etc. That's no longer an issue. You can pretty much put anything anywhere you want. You do have to be conscious of current draw and load, but you're not as limited as you used to be. Up here we have two tags that we're going to use. We're going to remember slot 1 is an output card, but you have three tags there: configuration, input, and output. Remember, an output card does have data that is input back to the processor. The input card has data back to the processor, and the data that comes to it is configuration, the same as this configuration tag up here. Our actual working data is local slot 1 output data, and there's our 16 outputs. We'll close that up, and here is our 16 inputs, and in the lab manual we show that. So I also in the manual have a graphic that points to the different bits and indicates what non-IO tags you're going to alias to these IO tags. So let's do that now. So we'll close this, and go back to the logic. We'll go to conveyor first. Going through the logic here and picking out our tags to alias to I/O. Of course, system run enable is just an internal bit that may be hooked to an HMI if you had an HMI. In our case, we're just going to toggle it on and off from the keyboard. So to conveyor running is actually needs to be alias to an actual I/O. And if you look at the chart, you'll see that there are two conveyor calls. So there's a line 1 to conveyor call and a line 2 to conveyor call. Now here I say to conveyor running. It suffices to say that we did explain earlier that we're using this input to signify that the downstream part of the process is calling for product, calling for cartons. But technically the name of the tag would be to conveyor running, because that's actually what it is. It's the aux contact from the motor starter for to conveyor. So we're going to alias this one. So let's go edit the properties. It was created as a base. Now we're going to change it to alias. And I have showed you several ways of doing this. The easiest is to right click in the alias for field and type in L. So that takes you right to local. And then drop down the list. That skips all these tags up higher here. See, up there. So you don't have to scroll down. We go to local, and then this is an input. Go down to slot 2, data. And if you look at your chart for line 1, a to conveyor running is bit 0. So we pick bit 0. And notice where the scope for this tag. It's in line 1 conveyor. And when we do this same process for the other program, it'll be line 2 conveyor. Apply and OK. OK would have done the job. You don't always have to hit apply. I tend to, because there was a day many years ago when if you didn't hit apply and you just clicked on OK, it didn't actually take the edit. And I'm not talking about 5,000. I'm not even talking about necessarily 500. I'm talking about some other products that put me in the habit of hitting apply and OK. Okay, the next tag, we'll just go through and alias these. It doesn't matter what order you do them in, but I think in the manual I had you do the output, run 1 conveyor next. Run 1 conveyor, edit. We want to make it an alias. Again, local. Only this time it's going to be an output, right? So slot 1, O for output data. And in the chart for line 1 conveyor motor, we showed bit 0. Okay. Now looking at the rest of these tags, 1 PE blocked, edit, alias, local, and remember this is going to be an input, so we go down to input, data, and for 1 PE line 1 we want bit 1. And for 2 PE blocked, and now watch, both these tags right here are Booleans. These are the same tags. Both of these instructions, true if off, true if on, read this memory location, 2 PE blocks. So it doesn't matter which one. We'll do this one. Really doesn't matter, because we're editing that tag, not the instruction. Alias. Type in something to get us close. Data. Now, 2 PE is bit 2. Notice both of these now show the alias IO tag. Now, there's nothing else in here that, this is an internal bit. That's a register that stores a count. Same register. So everything here is covered. We've aliased everything we needed to alias in this piece of code. Okay, now we go to, oh, by the way, I'm going to delete this one, or close it rather. So we only have just the 3 that we're working with right now. And of course, in the main routine, I see I deleted the wrong main routine, no problem. I hope I didn't delete the code in it, just to make sure. I'll close that and open it up again. Yeah, I did. I accidentally deleted the code from the main routine in line 1 conveyor, and it's looking line 2 conveyor. I see it's still there. So what I'm going to do, that's selected. I'm going to hold down the shift key or the control key, either one would do in this case. Now they're both selected. I'm going to go control C on the keyboard, go to this main routine, control V, delete that unfinished rung, and now we're back in business. I don't know how I did that. When I was doing that whole third program thing that I turned around and deleted, that was not part of the lab, and that was not planned. That's what happens when you do things that are unplanned and unconsidered when you start. But I think it still works out okay. You saw how to delete a program that you didn't want. Basically, you really had to unschedule it. And in other words, 5000, RS5000 has to think that it's not being used before it lets you delete it. If it doesn't think it's being used, then it will let you delete it. Okay, so we're back in business here. And we're going to, that's line 2, so we'll close this one. Just leave, open up conveyor, that one's alias production. Now there's really not much in here that needs, except for 4PE it looks like. This tag was already aliased in our, when we were working in the conveyor code. So we'll scroll down here. We know we have to do this one, so we'll go ahead, right click, edit properties, alias, LO, just L would do. And it's a photo eye, data. And then from our chart, 4PE is bit 4. Now I don't think we're going to use 3PE in this particular lab project. Typically, whenever conveyor segments, we'll call them segments, whenever there's a transition between one mechanical segment and another, there's usually a photo eye at the exit of one and the entrance of the next. That's not always the case because material handling companies tend to save every buck they can. If they can eliminate some photo eyes that they're not using, they do it. And then when you commission the project in the field, in other words, you're in the customer's facility, in the manufacturing facility, and you're commissioning the material handling system, and you need that photo eye, well, then you can add it back in. So we're going to leave that in there, though, because we have a rich customer that likes a lot of photo eyes, so we'll just leave 3PE in there. And you can see we do have a bit for it in our cross-reference there that was right on the very first page of aliasing tags to IO tags. Okay, let's look down through there and see if there's any others. None. So we went through and aliased all of the tags that we needed to for line 1. Now, I can leave these open. I will leave them open. So we'll go to conveyor for line 2. So you just don't want to get confused. There's conveyor, see it says line 1. And there's conveyor for line 2. That's the one that we have right here. So now we're going to do the same process all over again. Now, this tag is identical to that other tag until we alias it. And it's still an identical tag in a sense, but it's pointing to a different location. So I'll go down to data. Now this one is 5. Okay, and then run conveyor 1. And it's still one conveyor because one conveyor is part of line 2 conveyor system. So you have a line 1 conveyor system and a line 2 conveyor system, but within each of those systems there is a gravity conveyor, a 1 conveyor, and a 2 conveyor. Those are subsets of the set line 2 and the set line 1. So there's a tag structure here, and there's a path. So actually, this tag right here, you could say is line 2 underscore conveyor dot run underscore 1 conveyor. Now you're not going to see it that way, but that's basically the path. The path is into the program, into the logic. So we'll edit the properties here, alias, local drop down, this is an output, and it's probably going to be bit 1. Yep. I'm looking at the same cross-reference you are in the manual. And now we need to alias the photo eye, 1PE, alias L, drop down. This is an input data. Now we skip photo eye 3, so it's probably going to be 6. Let's look here. Yep, line 2 1PE is bit 6. Okay, we need to do 2PE. You see, after you do this a couple hundred times, it becomes fairly quick, and you learn the little shortcuts. The only thing you're going to run into is sometimes when you have this pop-up right here, that this stuff will be down below the edge, and you have to click, 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 over here, scroll down, click, click, scroll down, click. That's the only unpolished edge on RS5000 is this little pop-up here. Sometimes it pops up out of your view and you have to scroll down to get it. Okay, so this was 2PE for line 2, which is bit 7. And that takes care of us here. So we go to production and we need 4PE. Alias L for local, drop down, data, and it's probably going to be bit 8. No, it's going to be bit 9. It's going to be bit 9 because bit 8 would be 3PE. And you could go in and actually edit those tags in the missing spots for the 2 3PEs. As a matter of fact, we'll just do that. We'll go into program tags here, and we'll go to 3PE blocked. Well, actually, we don't have a tag called 3PE block, so we'll go to edit tags and underscore 3PE underscore and we'll create a tag and we will alias it. Now we could type in L here, do the same thing, drop down, go to data, and now we can't do the other 3P here because we're in this program tags. So we go to this program tags, different one, edit tags, and do the same thing again. Now if we'd created this tag before we copy and pasted the whole program, this would be done. So this is kind of an afterthought, and this is unnecessary if we're not going to use this tag, but I mentioned it, so we'll do it. Now here I didn't type L, but I scroll down 8. Okay, now the tags are in there. So if you change your mind, or I should say, if in the field you decide you need 3PE, the minute you start typing in underscore 3, it's going to pop up. And hit enter and it's selected. You don't have to alias it, it's already done. And we did set those bits aside, bit 3 for 3PE in conveyor 1, and then bit 8 for 3PE in conveyor 2. Now we don't have enough IO to do a whole bunch of these conveyors, because we could keep on going. And if I were to right click on either one of these two, because they are identical, because I did add this tag to both. If I were to right click on either one of these, copy, main task, paste, we would get a third program, as you know, and then we would change it to line 3 conveyor, and then we would go in and edit the I/O. We don't have enough to do a whole bunch of these, and really I only wanted to show you this procedure of how easy it is to reuse your code. Now remember, when you look at the tag databases, they still look identical in a sense. If we look at this one right here, this is for line 2 conveyor. If you look here, everything's identical. So program tags for line 1. We were in edit tags, that's why it looks different, but the difference, however, is right here. Data 102403. Go back here. See different numbers. So they're aliased to different actual I/O points. So the question is, where are these tags located? And where are these tags located? These tags are located in line 2 conveyor program tag database. These tags are located in C for controller, C for controller. So see, these are all controller tags. If we go back to line 1 program tags, C for controller. So this is the controller tag database, and this is the program tag database. Now that doesn't mean every time you open up a tag database, this is controller and this is program and this is controller. No, I'm just saying that when you open up a program tag and you look and you see an alias 4, you won't see a C over here ever in a program tag database because they're program tags. Okay, I think we beat that up enough. Save, download, and go online with your project. The last step here I had you do was and of course it pops up because that's the last place we were at, and it already says download. I mean, this is already active because it's pointing to the controller. So we're downloading now. And we're going to go online, and I could execute this program. We'll close down the tags. I could execute this program now if I said, I'll just toggle that bit. Now notice I toggled a bit, but it did not go on. Can you tell me why? Now of course I can't hear you, this is a recording, but what should pop in your head is maybe he didn't turn on. Well, let's do that a little slower. Right click, toggle bit. Well, the controller I/O update is faster than the hand, so it did go on for an instant, but it went right back off because this data right here, local 2i data bit 0, is coming from this IQ16F down here. And if I open that up, the connection is 20 milliseconds. The RPI, requested packet interval, is 20 milliseconds. That means every 20 milliseconds, this input card tells this processor what the state of those inputs are. So even though I typed in or toggled it on, within 20 milliseconds or less, it turned it back off because the input is not actually turned on. Before we alias to real I/O, you could have toggled the bits and executed the logic. Now that you have it associated with another location in memory, in other words, 2 conveyor running is pointing to this tag, and this tag is points to a memory location that stores the state of that input from that input card in slot 2. If you wanted to execute this logic, first of all, you have to either have 5000 emulate or you have to have a Logix processor, control Logix, compact Logix, soft Logix, flex Logix. You have to have the Logix engine in hardware to execute the code, whether it's emulate, which is really soft Logix 5800. They're basically the same thing. And so you have to have the Logix engine to execute the code. So if you don't have that, then it's irrelevant. And the process that you just went through would be identical to what you would see if you had a processor to download the program to. You would see this behavior. Now, if I was offline and I toggled this bit, and to prove that, let's save. Always save before you go offline, unless what you have offline you want to keep. And if that is the case, you should go and change the name of that first, then save and upload. Okay, so we saved. Let's go offline. Now if I toggle this bit, it toggles on, but it's not executing code. If I increase this value to 4, this is true, this is true, this is true, but that's not going on. Okay, so I am altering the state of the bits in the offline image of the data table, not the online image. Now I'm going to download this. I'm going to go Communications, Who Active. So not only am I downloading the program file, I'm downloading the database as well. So it's going to download a 1 for that tag that I just toggled on. But you're going to see that when we go back to the run mode, it's off, because the instant it went back to the run mode, well, even before it went to the run mode, that I/O card is updating every 20 milliseconds, whether you're in the run mode or not. As soon as I downloaded, that bit was back to 0 based on the input. I don't actually have my input or my I/O fixture hooked up to my controller, so I can't reach over and hit toggle switches to simulate photo eyes, etc. So anyway, that takes care of this lab pretty much. The other things that you had in the manual that we're not going to show on the screen is I did some graphic comparison of the two tag databases and pointed out the same differences that I pointed out here. I also included some information on a continuous task, periodic task, and event task, and some examples of what type of task you would use for certain types of applications. So thank you for watching. We'll speak to you in the next section. Thank you for watching this lab discussion video on reusing code out of the Conveyors lab. There are a couple more sections to this lab, all under conveyor code. There was the code itself is the GSV instruction, some production code, and then this discussion that you just watched.